everybody. Now today let us see programming language and graphics unit. Okay, so we'll solve the problems. Here the problems. Here first problem, a 3D triangle with points given. 3 points are given. Apply shear parameter 2 on x-axis, parameter 2 on y-axis, and parameter 3 on z-axis. Find out the new coordinates of the object. So this is a 3D shearing. Okay, so first we'll write the coordinates. So given the full coordinates, that is let us take a b c. So the coordinates are a 0 0 0, b 1 1 and 2, then c 1 1 and 3. So here we have to apply the shearing parameter 2 on x-axis. So we shall take sh, that is shearing parameter for x is 2, shearing parameter of y is 2, and shearing parameter of z is 3. Okay, so we have to find out the coordinates of the new object, that is means coordinate of the object, that is after shearing what are the coordinates of the object. So here we have to see that shearing can be applied on the x-axis, shearing can be applied on y-axis, and shearing can be applied on z-axis. So when shearing is applied on first, when shearing is applied in the x-axis, what is the formula? So the new points will be like x new will be equal to x old, and then y new will be equal to y old plus shy of x old. Similarly, z new will be equal to z old plus shz of x old. So based on this formula, we can apply this formula for the 3 points so that we can get the new points. Okay, so now we apply the first a 0 0 0 to get the new point, that is a dash. Let's take a dash. So x new is equal to x old, so the x value remains the same, so write 0. Now y new is equal to y old plus shy of x old, so y old is 0, so this is the old values, right? So y old is 0, 0 plus shy is 2 of x old is 0, so 0, so value is 0 only. Next z new is also z old plus shz, that is 3 of 0, which is also 0, so this is the new value. Next we will see the next point, that is 1 1 and 2. So apply the same formula. So x new will be equal to x old, so x value does not change, so write 1. Now y value will be y old, so y old is 1, and shy is 2, and x old is 1, so 1 plus 2, which is 3, so y value is 3. Z means z old is 2, shz is 3, 3 of 1 which is x old, so 3 plus 2 plus 3, which is 5, so 1 3 5. Similarly for C point 1 1 and 3, so C dash will be so x new will be equal to x old, so write the x value as it is 1. Next y old will be y new will be y old plus shy of x old, so here you write 1 plus 2 of 1, which is equal to 3. Then next z value is 3 plus 3 of 1, which is 3 plus 3 is 6. So the values will be 1, 3 and 6. So the new coordinates when shearing is applied on the x-axis will be 0, 0, 0, A, B, 1, 3, 5 and C will be 1, 3, 6. So in this way you can find the shearing is applied on the x-axis. Now if you want to find the shearing applied on y-axis, so we'll write the formula, okay, similar to this only, but it will be different. We have to take as y will be y new will be equal to y old, and we have to apply this formula for shearing in the y-axis. I shall write the formula, then we can do the calculations. Okay, I shall just write the formula. If they ask shearing on the x-axis, means this formula. If it's shearing along the y-axis, shearing is applied on the y-axis. When shearing is applied on the y-axis means the formula will be y new will be equal to y old, x new will be equal to what? X new will be x old plus shx of y old. Similarly, z new will be equal to z old plus shz of y old. Okay, when shearing is applied in the y-axis. Now we have to apply the points in this formula. Similarly, for write out the formula, you can calculate. Okay, not a big issue. So shearing along the z-axis will be z new will be equal to z old, and then x new will be equal to x old plus shx of z old, and y new will be equal to y old plus shy of z old. So in this way you can find out the, by means of the formula you can find out the new points. Okay, based on the question we can find out whether the shearing is along the x, y or z axis. So apply this formula to the old coordinates and get the new coordinates.